Okay, so 7.2, we're using elimination. Okay, we've done substitution, we did graphing, now we're using elimination. Elimination is exactly what it sounds like. You are eliminating variables. So on the steps of those, they're two different colors just because I made them two different colors, no other reason. Okay, so the method of elimination. First, you obtain coefficients for x or y that differ only in the signs by multiplying all terms of one or both equations by a non-zero constant. So I want to get a variable that will zero out. That's what I want to get. That's all that means. Okay, sometimes I can just multiply by a negative. Sometimes it needs to be a 2. Sometimes it needs to be a negative 6. Sometimes I need to multiply both equations by something. Remember when we were getting common denominators and the questions from the other day, we had 5 and 2, right? If we had to get x and we had a 5 and a 2, we'd need to multiply 1 by 2 and 1 by 5 to get 10. Okay? So the whole point is to eliminate. Eliminate means 0. Yes? The next step would be to combine the equations to eliminate one variable. Third step would be solve the equation from step 2. And the fourth would be back substitute to find the value from step 3 into either one of the original equations and solve for the remaining variable. Check your solution set. So that would mean at some point in there you made a solution set, yes? An x and a y. Now, when we come back from Thanksgiving break, we will be not doing 2 equations, we will be doing 3. So when you have 3 equations, guess how many variables you have? 3. Okay, anytime if you have 5 variables, you have to have 5 equations to have a unique solution. A unique solution means one solution that makes them all true. Okay? So if you ever don't have enough equations or don't have enough variables, there's going to be a change in that. And we'll talk about that more as we go. The reason I made these in different colors is just so it distinguished the steps. Okay, so first we have to make a variable be able to eliminate, correct? By multiplication of a non-zero. Sometimes it means we multiply one equation. Sometimes it means we multiply what? Both. You just have to do what you have to do. You pick the easiest one. Now, if I ever, after this, other than saying you have to use Gauss-Jordan elimination in Chapter 8, tell you that you need to solve the system of equation, I don't care if you use substitution or elimination. Graphing would work if you had a calculator, but other than that, it would be an estimate, and that wouldn't be very good, would it? So, I don't care elimination or substitution. You should do what's best set up for. Okay? But that's where we are. Are you guys ready yet?
Yes.
I know, but you're still writing, right?
You forgot to take your head with you yesterday. You don't think?
I'm going tonight. What am I? I didn't go yesterday. I don't know why this is so small, but that's okay. Okay, I'm good now? Maddie, you good?
Yeah.
Okay. So, we're supposed to solve the linear equations by elimination. You look at it, and you decide which variable needs to be eliminated or would be the easiest to eliminate. Evan?
Well, you can either do the top or bottom, but you want to solve for x because they're the same number.
You want to eliminate x.
Eliminate x.
Eliminate x, yes. We don't want to solve for x, no.
No, I'll get rid of
Okay,
x.
we want to, now, we could eliminate the x's. We look at that because it's 3x and 3x, yes? One of those needs to be a negative.
Multiply by -1.
Okay,
3x
just a
minus
second,
3x.
just a second. Okay, could I choose to do the y's?
Yeah.
Yes, if I chose to do the y's, I wouldn't just have to multiply by a negative, I'd have to multiply like 1, I'd multiply the top by 2, the bottom 1 by 5, and one of those would have to be negative, correct?
Correct.
So it doesn't matter, some are easier than others to do. Got it? Okay, your phone needs to be put away. That's why phones on Monday are going to be mine, because you guys cannot leave them alone.
Write it down.
No. Okay, so top or bottom do we want to multiply by a negative?
Top.
Top by a
Well, it
negative?
doesn't matter.
Does
Either one.
anybody?
Actually,
Well, I'd say
bottom
the bottom
because
I am
it's
Jeff,
rather
the
bottom.
Okay, bottom because you guys just want to see that go, right?
Yeah.
Okay, but everything by negative. So it makes it -3, -2, and negative 1. I'm a big one for just rewriting it underneath because I've already written the problem once and I don't want to do it again. And then I combine. I do not say add, I do not say subtract because you already set up the subtraction, yes? Just combine what is there. There's really no addition subtraction. Did you know that? There's just positive and negative numbers and we combine them. That's all it is. So I have a positive 3x and a negative 3x, so I have what? 0. I have 5y minus 2y is 3y. 7 minus 1 is 6. And then I divide by 3. So I get,
Y equals.
See, that one's easy, but I'm like,
okay,
Now
y
I
equals
plug
2.
in-
So now,
You plug that
Plug
into
in
the top.
2 for.
does it matter the top or the bottom?
No,
No.
I want to do the bottom.
Please do the original, not after you change it. Got it?
Got it.
So do you want to do the top or the bottom?
Bottom.
Bottom?
Yep.
So I have 3x plus 2. Make sure you use parentheses. Equals 1. So this would be 3x plus 4 equals 1. So 3x equals negative 3 and x equals negative 1. And my last step is to
Put it in a
Or like make them
order pair. And should I take a minute to check it? Yeah, you guys never do.
Wait.
But I love it when you guys go, am I right? I don't know, check. Okay, so that'd be a negative 3 plus 10. Is that 7? Okay, it'd be a negative 3 plus 4. Is that 1? Yes. It doesn't take that long to check it, does it? Once in a while you'll have ones you gotta jot down a number or two, but you should be able to plug it in there and piece it together pretty quick.
Wait, how'd you check it?
I just plugged in my x and my y into the both. Do they have to make both equations true?
Yes.
Yeah.
Or it's a no solution.
Or it's a no solution. Or you did it wrong. Okay. Solve the system of linear equations. I have 2x minus 4y equals negative 7. And 5x 5x plus y equals negative 1. This one is easier than, oh no, I don't think it's easier, but it's not hard. You could make it hard. I'll tell you that.
I'll probably find a way.
There's usually an easier way if you're getting it all. But sometimes they're just hard. Done? Okay, thank you. Can I start working?
Yeah.
Yeah? Okay.
I did something wrong.
I did too. I got a fraction. Same.
Hey, check your work.
I mean,
Fraction does
fraction
not
is
mean
right.
it's wrong, does it?
Yeah.
Your world is not all nice numbers. Check your work.
What was your question?
Yeah, negative.
Oh, got another fraction.
Get negative 1/2 for x?
Yeah.
There's
Okay,
something
see,
wrong.
Hold on.
just because it's a fraction does not mean I'm wrong, does it?
I think I just can't add. That's my problem.
Well, you know, that may happen.
Oh, I didn't mark it as a -7, so I got like a 3 over.
I feel like my next number's wrong.
Okay, now we're good. I just didn't read the problem.
Oh my god, I got it
Yes, I
wrong.
got it
Wait, what's happening?
Go.
Okay, now plug it in. Guys, plug it in. I don't know, I may be wrong.
No, you're not, because I got the same answer.
I also got the same.
Well,
You're
we
both
all could be wrong.
No.
We're all just bad.
So, half of 2 is
1.
negative, right?
Yeah.
And then 2 goes into 4 twice, and 2 times 3 is 6. Is that -7?
My mask.
X
Yeah.
is negative 7.
And now I'm going to have more fractions because I'm going to have negative 5 halves plus 3 halves. Is that negative 1? Yeah, because it'd be negative 2 over 2. Okay? Just because you get a fraction does not mean you're wrong.
What?
What are you going to do?
My mask broke.
You're going to walk around like this all day?
No, I'm gonna fix it. It whipped me.
Or just go to the.
Or just go get a new one in the office?
No.
Okay.
No.
Now,
Can you go back? Yeah. I missed all of that.
Now, what we have made here while you guys are writing, these, well, I'm going to rewrite it over here. When we multiplied the second equation and we had this, right? That's what we had there. Those are called equivalent systems. Equivalent systems just means you've multiplied by something. Since I multiplied everything by 4, did I really change it at all? No. I just increased the numbers by a factor of 4. As long as I do the same thing to everything there, I can do it. Okay? You guys done with the slide? Then I can get
I
to
have
it.
a question.
Yes.
Where are negative 1 minus 6?
I'm plugging these into the original to check. And so negative a half of 2 is negative 1. And 3 halves of 4, 2 goes into 4 twice, 2 times 3 is 6. So it'd be negative 6. Okay, so what we have there are equivalent systems. We are going to be working with, in Gaussian elimination, we are going to be working with equivalent systems. Okay, and those of you who don't like to show work should love this method because you do so much of it in your head with equivalent systems. So, I just want to make sure you understand that these two, this, and what we made are equivalent. We don't say they're equal, but they are, in essence, the same equation. Just because we multiply it by something does not change what your outcome is going to be. Okay? Yes?
Did you put those into the like the original bottom equation? Okay. Then could you use the top one too?
I did. I put them in both.
Oh, okay.
This is the top, and this is the first one and the second one.
Okay.
So we're good now on this one? Okay. So again, this slide just says these are equivalent because we multiplied them by a non-zero constant. That's it. That's what equivalent systems mean. Okay. The operations that can be performed on systems of linear equations to produce equivalent systems. Now, you don't need to write this down. You need to understand what they are because you already have this stuff written down. Okay? When you wrote down your steps, your 1, 2, 3, 4 steps, you wrote this down. Okay? So I can produce equivalent systems by just interchanging two equations. So that means I could take equation 1 and 2 and write it as 5x plus y equals negative 1 and 2x minus 4y equals negative 7. Did I change the outcome of this? No. They're still the same. I just changed the order. And when, again, this is all leading up to where we're going, okay? So we understand that we can move things around and not do anything. The next thing is multiplying an equation by a non-zero constant, and I don't know what the and is. Okay, multiplying an equation by a non-zero constant. Well, I showed you that here too, right? How do we get from here to here?
You multiplied it by 5.
I multiplied row 2
By 4. Not
by
5.
4.
Still.
I took R2, 4 times R2. 4, yes,
Yeah.
times, because it's right next to each other. R stands for row. And what row? 2. We will be identifying what we're doing simply by that. What's nice about the process we're leading ourselves into, guys, is I could pick my notes up from 3 years ago and I can tell you exactly how I solved an equation without even thinking through the process. All I have to do is read the side and I can tell you how you got that. You guys are always asking me the question, how did you get that? What does this tell me? 4 times row 2. Okay? Oh, and I know what it is, but adding a multiple of one equation to another equation in the system. So when we were solving this equation, oops, we multiplied by 4, yes, and then we combined or added, yes?
Yeah.
I like the word combined, not add. Why is it going backwards? I would rather put combine because all we're doing is combining the numbers that we have there together. Like I said, there's no addition, subtraction, there's positive and negative numbers. If I have 2 negative numbers, I add the numbers, yes, and they're both negative. I have 2 positive numbers, I add the numbers, and they're both positive. What happens if I have a positive and a negative number? What do I do to it? Subtract, and how do I know what sign it is? The larger number. I use my basic integer math, right? Okay, so any system of linear equations is consistent when it has at least one solution. So if something has a solution, we call it consistent. A consistent system with exactly one solution is independent. One solution means -6, 4. That is the one place that they intersect, because if I drew the picture right, they'd be intersecting there. So it's called an independent solution. Now, a consistent system that has infinitely many solutions is called dependent. So infinitely many says that I could come out with infinite many points, right, as solutions. So we'll write an equation for your x and your y that you can find. So if you pick an x, then you plug it in the equation. You'll see, not yet, but we're going to do it. So when you get something that is infinitely many, we are going to, in the next few sections, learn what you do after you get infinitely many. It's not just a stop. It used to be you said infinitely many and you were done, right? Not no more. We got big kids now, right? So we have to give somebody a way to pick a coordinate pair. A system is inconsistent when it has what?
No solution.
No solution. So we will start writing inconsistent rather than no solution. I will take both, but the book will only say it's inconsistent.
A little love sign thing?
No. The book will only take inconsistent. So no solution means it's what? Inconsistent. And if you think about it, consistent, it has at least one solution, right? Inconsistent, it has
No
no
solution.
solution. It's not a hard concept to grasp. So I can have one solution, infinitely many solutions, or no solutions. Those are my only 3 choices. I can't have 2 solutions. I can have one, infinitely many, or none. That's it.
What if they're okay? This might be the definition. Never mind.
Ask it.
Okay, what if there's 2? Does that
There
mean
isn't
that's
2.
what- Okay.
There's one, infinitely many, or none.
So if you get 2, you did something wrong.
If you did 2, there's probably infinitely many.
Okay.
Okay? Now, we had quadratics. Okay, you had quadratics where they crossed and it had 2, yes?
Yeah.
Okay, so when we do things like that, but we're talking about equations that have the same degree,
Okay.
not 2 separate.
Oh, I
degrees.
got you.
Okay. Are we good with this? You guys good? All I have is one more slide, so if we're not good, it's just a picture of these.
Alright.
Okay, no one's yelling. Okay, so all these are pictures, guys. You don't have to draw them if you don't want to, or you can just click sketch. How many solutions do you think A has?
One.
Infinitely many.
Infinitely many. Why?
Because it's just one line that goes to add.
It's just one line, so that means they're both the same line.
Wait, how do you? Ah.
Do you see? There's only one line here, isn't there?
Oh, I thought you were talking about like A.
No, one. Sorry.
That's okay. I got
Okay, I. Just number 1. This would be infinitely many, yes?
Yeah.
How many would this be?
That'd be no solution.
That'd be no solution because they don't touch.
Cross.
What would this one be?
1.
1.
Because they cross.
Okay, so it'd be one unique solution. So what we're supposed to do is match these up, right?
Yeah.
So this one would be the two equations that are exactly the same in essence. So do you see?
That's C.
See why?
I don't know.
It's
Yeah.
just the top equation.
Because you can take the
Now
the
wait-
bottom
now wait a
one times
second.
2.
Is it okay? Wait, is the top equation by what?
-2.
Negative
So if I multiplied this by negative 1/2, multiplying by negative 1/2 is the same by dividing by negative 2. Yes.
Yes.
We won't divide. We'll multiply by fractions. Okay.
Okay.
So when I do that, I get 2x. Yes.
I get my headphones.
Mhm. Minus 3y equals 3. So this would be C, wouldn't it? Because they're the same equation.
A is almost exactly like that one.
A, okay, so let's look at A. So if I was going to use elimination, you'd multiply the top by what?
Wait, the top?
By negative 2.
2. Positive 2.
2 or no,
Negative
negative 2.
No, now wait a second. I have opposite signs. I don't want to be doing a negative, do I?
Because if you
No,
take
but look. I have a positive 2x and a negative 4.
Multiply
X.
by 2.
I don't need to multiply. If I multiply
you
by a
don't need to get the
negative, I
same-
change the
yeah.
sign. I don't want to do that, do I?
Yeah, we're gonna go by
So,
five.
Now, could I multiply equation 2 by a half if I wanted
No,
to?
we're not going to.
Yeah.
So.
Okay, so we're going to multiply this by 2. So I get 4x minus 6y
This is the solution.
equals 6.
This is one solution.
That's no.
No, this is the no. Why don't
So what am I going to get over here?
0.
0 equals
0?
0.
6
Oh.
plus 6
Oh,
is
Twelve.
12.
So no solution.
No,
Does 0
solution.
equal
No.
12?
No.
No. So that's my no solution.
Oh, damn, we don't even have to.
We don't even have to do the other one. But we could, right? And the
No.
answer we should get is what? 3,
1.
1.
So
Okay.
if that, so the
Can we
middle one
just
is
do
no
B?
solution.
Yes, we can do
I'm
B.
sorry, can we do B?
Okay. So what variable would you like to eliminate? X or Y?
X.
X.
Off of the bottom one.
Okay. Now, just a second. Why did you choose X, Tori?
Because there's no variable on the X and,
There is a variable.
well, there's
It's
one,
one.
and it's easy to just multiply by negative.
Right. So she would just have to multiply by negative 2. What if I said I wanted to get rid of y's? Because I have people that go, oh, it's a positive negative, I'm going to get rid of my y's. If I get rid of my y's, I have to multiply both equations, yes?
Yeah.
Yeah.
But we are going to do that because we haven't had an example like that. We're going to get rid of the y's. So 3 and 2, what is the least common multiple of 3 and 2?
6.
6. So that means I'm going to multiply the top by 2 and the bottom by 3. We don't need to do a negative because one's positive and one's negative, correct? I don't have a whole lot of space here. So when I do that, I get 4x minus 6y equals 6. Yes?
Yes.
And 3x plus 6y equals 15. So now I combine, yes?
Yep.
So I get 7x equals 21.
X equals 3.
So x equals 3. And now I plug that back into one of them. You probably pick the
bottom one.
second one, yeah?
Yeah.
So it'd be 3 plus 2y equals 5. Now, I'm going to tell you before I plug it in, I would do this.
So it'd be
I would do 2y equals
2.
5 minus x and divided by 2. I would move it over before I plugged it in, personally.
What?
I would solve
You-
for y before I plugged it in.
Okay, well,
Because you should have learned this from science. We always should manipulate an equation before we start plugging in numbers because it's easier to manipulate variables than like 3.6, 8.9, things like that. Okay, so now I plug in what, 3?
Yeah.
So 5 minus 3 over 2, so 2 over 2 is 1.
1.
And we have 3, 1, and is that what the graph said?
Yeah.
Yeah.
Yes.
Wait, doesn't that change your, what, the 5 and the 3?
Please don't do that.
What do you mean?
Like when you multiply it. So we take 2 times the first one, the 3 changes to the 6.
Yes, but when we plug it back in, we go back to the original. Because you have smaller numbers. Okay? So, we're going to try to use the WebAssign, yes?
Yeah.
And just because
Make
they're
sure
a
to
different
change the
number,
due date.
if I need help and somebody can help me, I'm gonna use the same procedure, yes?
Yes.
I'm just gonna get a different number.
Make
And there
sure-
is question help on WebAssign, use it. Yes,
So the first graph is dependent and then no solution and then independent?
okay, no, the first is inconsistent. Wait, sorry. It's consistent, dependent is graph number 1.
I have to put both.
Well, it's consistent meaning it has at least one solution, yes? And it's dependent because it's the same. Okay, so the next one is what?
No solution.
Inconsistent or no solution. The third is consistent and independent. Because it has one answer. Consistent, independent
So the
is,
first one was dependent and had one.
the first one is consistent, dependent.
Means it has multiple answers.
Yes, and it depends, what the dependent means is my y depends on what x I put. That's what it means. And you'll see that as we solve, we have equations for those.
Just make
Yes.
sure you change the due date on that one.
Yes,
Even if
I
it's-
will make sure I change the due date on the assignment. Can you even open it yet?
You can
I can
open it,
open